One more problem from the electric circuits, and we have to find out the potential at A. So we have to find out the potential at A point. If we know potential at B, so in this problem VB, the potential at B point is 0 given. So the potential at B point is given 0 value, and we have to find out the what is the potential at A point. So if you want to solve it this type of problems, and we have to know the sign convention rules for the KVL, and I have to explain first of all, then go for the this problem solution. Okay now. So if you go, for example, in the circuit we have battery or cell. So this is my symbol of the battery or cell. If you are entering, so to solve the any type of problem in the circuit, you may prefer direction either clockwise or anti-clock. For example, if I entering into the positive terminal of the battery, that EMF, for example, it has 2 volts is there, and when you entering into the positive terminal of the battery, this EMF we have to take it as a negative, we have to assign minus, that is a minus 2 volts. Otherwise, if you are entering into the negative terminal of the battery, that EMF of this battery you can take it as a plus 2 volts. Okay, this is about the battery or cell. And go for the resistance. In the resistance we have so many circuits, in the circuits we have so many resistors are there, and this is my resistance R. Okay, so this is the current and the resistance is in this direction, and the sign of the voltage across the these resistance depends upon the our direction and the current direction. For example, if you go along the current direction, the sign of the voltage drop across resistance is negative. V is equal to minus of voltage drop across resistance, that is current in this element I, and value is R, minus I into R. Okay, next, otherwise if you are entering, so this is the direction of the current and the resistor, and also if you are entering, so we are going opposite to the current direction in the resistance, and we can assign the sign is plus I into R. So these are the rules we have to remember to solve this type of problems. Okay, so we go for the problem. Right, so we have to find out the what is the potential at A point. If you know potential at B point, okay, what is the potential at B point? So he has given 0. Okay, now we are going to go from A to B. So which is a higher potential? So a current is coming from A to B or not? No, this is a higher potential, is lower potential. Current is always flowing from higher potential to lower potential. Now we have to apply KVL from A point. Higher potential, this is a rise. So I can take VA, the potential at A point, VA, and so it is my direction. I'm going from A to B, and what is the current in this element in this direction, which is along my direction or not? That's why we can take sign of the voltage across the resistor is minus I into R. What is the current in this element? I, resistor value 2. So 1 into 2. And also we are entering into the positive terminal of the battery, so we can assign the sign is minus. So how much voltage here, how much EMF is there? Minus 4. And also we are going along the current direction in the resistance, the sign of 3 ohm is minus. So 3 into the current and the element is 1 ampere into 1, 3 into 1, and lower potential we can assign minus VB and is equal to 0. What is the KVL? Algebraic sum of the increase or decreases voltages across elements. All elements in a closed path is equal to 0. That's why I can assign 0. Okay, now I want to solve for VA. VA and minus 1 into 2, minus 4, minus 3, and minus VB. What is VB value? 0 equal to 0. Now VA is equal to minus 2, minus 4, minus 6, minus 3, minus 9. If you bring that side, this is a 9 volts. So the potential at VA is equal to 9 volts. Okay, students, so ఈ ఛానల్ మీకు ఉపయోగపడుతుంది అనుకుంటే and subscribe and share it, and if you want to see full videos, and subscribe my channel. Thank you.